Jacob is using his scale-o-matic machine to change some toys to a larger size. He needs to program the digital multiplication dial to the correct setting so each toy will be enlarged to the desired length. The values on the knob indicate how many times larger the scale-o-matic will make the object. Jacob's toy surfboard measures 5 inches in length, and he knows that he wants the new length to be 10 inches after it is enlarged by the scale-o-matic machine. He wants to set the multiplication dial to the correct setting to scale the surfboard up to the larger size. Jacob realizes that 1 times the 5-inch length would be 5 inches, so that can't be the right setting for the dial. He thinks a number line is a great tool to represent how the scale-o-matic will scale the surfboard length up from 5 inches to 10 inches. Jacob uses a green bar to represent 5 inches, and he decides he will need another 5-inch bar to show a length of 10 inches. Now Jacob can see that he would need to scale up to 2 times the original length, which can be represented with the equation 2 times 5 inches equals 10 inches. Jacob can say that the scaling factor is 2, so he needs to set the multiplication dial to 2. Jacob's snowboard measures 4 inches in length, and he wants to enlarge it to 12 inches using the scale-o-matic machine. He draws a number line again, and he uses the orange bar to represent a 4-inch length. Jacob realizes that he will need 3 4-inch lengths to make a length of 12 inches. Jacob scales his toy snowboard's length up by 3 times, which is represented with the equation 3 times 4 inches equals 12 inches. In this case, 3 is the scaling factor, so he needs to set the multiplication dial to 3. The length of Jacob's skateboard measures 3 inches, and he wants to enlarge it to 12 inches using the scale-o-matic machine. He sketches a number line again, and he uses the blue bar to represent the original length of the skateboard, which is 3 inches. Jacob notices that he will need 4 3-inch lengths to create a total length of 12 inches. Jacob scales his toy skateboard length up by 4 times, which is represented with the equation 4 times 3 inches equals 12 inches. In this case, 4 is the scaling factor, so he needs to set the multiplication dial to 4. Now Jacob can record the dial settings, which would be 2, 3, and 4. He just used those 3 numbers as the scaling factors to scale up. Multiplying by a value greater than 1 allowed Jacob to increase the product. Jacob's backpack is packed really full, so to create more room he came up with the idea that he will shrink some of the objects he needs to carry using the scale-o-matic machine. This table has some of the information that Jacob knows. The object names and their original sizes are listed in the first column, and the third column lists the desired new size. Jacob insists that he can use the multiplication dial again to indicate the scale factor, but this time he is scaling the object down in size. Jacob also remembers that when he multiplies by a value greater than 1, the object's size increased. But how can he scale down using multiplication? Help Jacob figure out correct settings for the scale-o-matic machine. Record the scale factor, which is the setting for the dial in the center column of the table.